So we're going to take a look at some of these object-oriented implementations over time. I've already talked about the Python inspiration. I flipped Python and C++ in the early days because at least Python we kind of know. C++ it was 1980, Java in 95, JavaScript in 95, PHP in 2000, and then C# in 2001. So here's the example that I showed you before. Talked about it before. You have a constructor, double underscore init, double underscore with self as the first parameter. Self.x, again, the key thing is self is by convention. Self is not a language construct. It just so happens that the first parameter of method calls is to the instance, and we almost exclusively use the word self for that. That is a very early 1991 implementation of an object-oriented syntax on top of a mostly procedural language. Now if we take a look at C++, C++ was initially implemented as a preprocessing pass, and it did one-for-one textual transformations, and so class was not a keyword in the C language. Public, that's not a keyword in the C language. There was syntactic transformation that kind of transformed it into C and then ran it through the C compiler. And so we say, and this is pretty elegant, and you can absolutely see how Python was inspired by C++. So class, point, open curly brace, double X and Y are the attributes, and the constructor by convention is it's a function that has no type. The constructor is the exact same name as the class. So in this case, I've got point with an uppercase P. And then the constructor parameters come in. Now, the interesting thing is you have to declare as double X and Y as the attribute variables. And then within the function, you can think of the double XY as almost like extern scope, means they're global across all functions. So you have this weird thing where you can't have a parameter like you could in Python. You can't have a parameter the same name as an instance variable or you'll be confused. And so you'll notice I called the XC and YC as my parameter variables so that I know that those are parameters in the constructor. And so I can copy XC into X and YC into Y. And it also means if you look at the dump code, you see you don't have to say self.x, you just say X and Y because X and Y are doubles. They're instance-wide extern variables, as it were. And the same is true in the origin function that's returning the square root of x squared plus y squared. You don't have to have self or this or anything else. So if we take a look at the main program, on that first line, point, pt open paren 4.0, 5.0, we are both allocating a point instance and calling the constructor and setting it up. Then we use the dot syntax, pt.dump, open paren, close paren, semicolon, to dump it out. And then we can call pt.origin, and then that will return us a double. And so you'll see this sort of dot syntax that becomes pretty common in every language that comes afterwards. So let's take a look at Java. Now recall that Java was inspired both by C and C++, and really wanted to be like the super language. And you see that it looks a lot like C++, but it does introduce the concept of this, so that it scopes the external variables that are the instance variables. You access an instance variable by saying this.x and this.y, rather than just x and y. And I think it's actually more elegant this way. So we say public class point, and then double x comma y, which are the instance variables, and then the constructor is using the C++ convention of point with no type. Double x and double y are the two parameters. This dot x equals x and this dot y equals y. Close curly brace. Now I like this better because using this does not keeps me from having to make weird function parameter variable names. I can make them what I want to be, and this is the way. Using this is the way that we contextualize that. So if we look at the dump method, we see the use of this, and this is not just by convention. This is a language element. So this is the pointer. You can see from the output, it actually prints out the class that it is and some kind of reference like ID-like thing. And so Java actually, if you start printing objects out, it tells you what its type and what instance it is. It's not necessarily an address, but it probably is related to the address somehow. But then we print out this.x and this.y. And then if we look at the double origin method, we see it's this.x times this.x plus this.y times this.y. So you see the sort of use of this throughout. And then if we look at the main program, we see point pt equals new point 4.0 comma 5.0. This is where we see the use of this new operator, where you're saying, look, call the constructor. And I like this. I like the sense that you're calling the constructor on purpose. You're not calling it implicitly. And then you end up with pt as the instance of this object. And so for me, this feels pretty good. pt.dump is a good example of calling a method within the instance, and pt.origin is similar. If we take a look at JavaScript, and recall that JavaScript is the weird one. JavaScript did not take its inspiration from C++. C++'s syntax was kind of influenced by the fact that it was initially a preprocessor to the language C. And some computer scientists would think that that's a rather impure way to think about object orientation. And so the JavaScript, when it was created, the idea is to be more pure in object orientation. And so the concept of first-class functions, because it has first-class functions, there is no class keyword. The class keyword was really useful when it was a preprocessor. The thing that JavaScript does take is the concept of this. Now, the interesting thing is if you look at everything on the screen from function point to the closed curly brace, this is the constructor. The constructor constructs everything. It constructs the attribute variables, and it actually constructs all of the methods as well. So if we look at the line this.party equals function open paren, close paren, open curly brace, we are setting, in a sense, an attribute variable to source code. This is an anonymous function. There's no name to the function, so most functions are named, but this function has no name. That's a JavaScript thing. It's a first-class function thing. We are basically not running that function with the two lines of this.x equals this.x plus 1 and console.log, blah, blah, blah. Those lines aren't running. They're being compiled, and then the code to execute that is being assigned into the attribute variable party. So it doesn't run it. It reads it and stores it in party. You can literally later print out this.party and you will see the source code to that function. And the same is true for this.dump. It's an assignment statement, and then similarly this.origin. And you see within those methods, you see this.x and this.y, which is taken directly from Java. We also see the concept of new in pt equals new point 4.0, 5.0. We're explicit, and I like this. I like the idea of saying, please call the constructor from the point class and pass these two variables in. And then we see the C++ inspired syntax of pt.dump to call a method in the pt instance, and pt.origin to call a method in the instance. If we look at PHP, now the key to PHP is PHP is a procedural language when it was created in 94, and then it became an object-oriented language in PHP 4 and then 5. It was late to the party, so it could be inspired by everything, by JavaScript, by Java, by C++, by Simula, by Scheme, all of those things. And so the PHP object orientation is kind of pretty as a result of that. Now, one of the things that happens in PHP is it's got some weird language syntax things in that variables have to start with a $sign. Thank you, Perl, for that. And the dot operator is used for concatenation in PHP, so we couldn't use the dot operator to look up instance variable or a method inside of an instance. PHP borrowed the C arrow operator, which is -sign greater than. Now the interesting thing is if you go back to pointers, the arrow operator is what you do when you have a pointer to a structure. And so in some ways that is a throwback to C in a beautiful way, because I think kind of under the covers, and as we shall see when we are starting to implement object orientation in C ourselves, we're going to see that pretty much we get pointers to, an instance is a pointer to something rather than a thing. And so we see this arrow x equals $x in the constructor. We see the constructor is a double underscore construct, so that PHP kind of used the single underscore and double underscore as sort of metadata about the meaning of things, and double underscore are things you're not supposed to call, they're supposed to be private. And then we have a function dump, and you see the concepts of this inside of dump. In origin, you see this. In the main code, you see $pt equals new point 4050. Well, it's following the new from Java and others. And then we call pt arrow dump, and then $pt arrow origin. It pretty much works like most of the other ones, except that you'd never use dot, because dot is concatenation in PHP. And I'll be honest, I love dot for concatenation, except for the fact that PHP is different than every other language that I use. Every other language uses plus for concatenation of strings. Now C# is 2001, so C# was inspired kind of by everything. And so you see that C# is clearly a very C++ oriented, but with some Java-ness to it. So you see the double XY in the class, which is the two instance variables. You also see that there's no use of this, and so you see that we have to name the parameters differently because X and Y are in effect global across the entire class. And then we have, void dump there, and then we see that it's just using X and Y. No need to use this. It's tough for me to decide which of these two ways I like better. I guess that this feels more explicit to me. So I like Java and JavaScript in that respect. I like self also. If we look at the origin function, we see x star x plus y star y. And so we don't need to use this. We again see a very Java-oriented point pt equals new point open paren 4.0 comma 5.0. Point dot dump, we're using the dot operator to look at instance variables and methods within the class, and then point dot origin. So now that we've looked at sort of a survey of the different kinds of object-oriented languages that are today, and we can sort of see how they derived ideas from one another, now we're going to actually try to build an object in a non-object oriented language. So we're going to build like a Python object in C.